Twin rig trawling has had more influence on the UK fishing industry than any other fishing method of modern times. Multiple rigs in general have been used for many years in several overseas fisheries to target specific bottom living species. The marine technology group based at the Seafish Flume Tank in Hull answers a regular flow of inquiries about fishing gear. Most of these inquiries have involved twin rigging. Despite the newfound popularity of twin rigging and its success as a fishing method, there is a surprising lack of understanding as to what really happens to the gear when it's fishing down on the seabed. This video film will give fishermen an insight into what happens to the gear as various alterations are made to it at sea. Twin rigging is a method of trawling that uses two nets side by side on the seabed. Two relatively small nets are used instead of one large net, because an equivalent area of seabed can be covered much more efficiently with two smaller nets. The usual setup is two similar trawl nets, 4 sets of sweeps and bridles, a pair of trawl doors to spread the gear, and a heavy weight, often called a clump. The purpose of the clump weight is to keep the center sweeps and bridles down on the seabed. There are two basic twin rig setups. One uses 3 separate warps. The other uses just 2 warps. The doors, clump weights, bridles and nets are similar for each setup. One of the main problems with any twin rig system is how to keep both nets square at all times. In both rigs, the tuning of the gear is normally done by alteration of the warp lengths. We shall look at the rigging of the gear to begin with. The first thing to ensure is that the rig is square. This means both nets should be similar. All 4 sets of bridles and sweeps should be the same length. The doors and clump, together with their associated chains and backstrops, should each be of equal length overall. This means that the distance from the towing point of the doors to the after point of their backstrops should be the same as the distance from the towing point of the clump to the after end of its backstrops. If the components are of equal length, then everything beyond the end of the towing warps is of equal length. Here we have an ideal situation. All 4 wing ends are in line. All 4 sets of bridles are in line. All 4 sweeps are in line. The doors and clump weight are in line. The doors are properly spread. This means that the nets are all symmetrical and in their ideal fishing position. But in order to achieve this, the gear has to be tuned. For the 3-warp rig, this is usually done by shortening up the center warp leading to the clump. This brings the nets and doors into line. For the 2-warp rig, it is more usual to add separate extension sections to the outside split warps. We are going to concentrate first on the 3-warp rig. Despite this rig having 3 separate warps, it is relatively straightforward to set up correctly. If we look at a 3-warp rig that has been shot with all 3 warps set at the same length. Here, the gear has been artificially held closed up to show that everything is of equal length. If the gear is now allowed to spread, it can be seen that, as the doors spread out and away from the clump, they describe an arc. The center of this arc is at the stern of the vessel. As the doors follow this path, they pull forwards of the clump weight. If we look at the nets when the gear is in this configuration, we can see that both are distorted, and the inside wings of both nets are hanging back. This creates a lot of slack netting, with open meshes in the inside quarter of the nets. If we look at the outside quarters of each net, we can see that the meshes are all closed up, with excessive strain on the netting. In this configuration, these nets would probably not fish very well and would be liable to damage. So, how do we get the nets square? To square up the nets, the center warp must be shortened so that it pulls the clump weight back into line with the trawl doors. But how do we find out how much needs hauling in on the center warp? If we assume that all the warps are straight lines when the gear is all level and square, we can form a right-angled triangle between one of the outside warps and the center warp, together with half the door spread as the base of the triangle. We know the outside warp length from what has been paid away from the winch. By using acoustic sensors or the warp divergence method, we can measure the total door spread. Halving this value gives the distance from the clump, which forms the base of the triangle. This leaves the center warp as the unknown side of the triangle. Using the triangle, we can then calculate the required length of the center warp. To simplify this, Seafish gear technologists have produced a set of tables for finding the center warp lengths corresponding with a wide range of warp lengths and door spreads. Looking at the table, we can see there is a range of door spreads down the left-hand side. There is a range of warp lengths along the top. In this example, if we were fishing with 275 fathoms of warp out and a door spread of 350 feet, we would look down the 275 fathoms column and across the 350 feet row in the table. Where they intersect, we find a value of 9.3 feet. This is the amount that the center warp should be shortened by in order to bring the clump in line with the doors, making the nets symmetrical. Remember, the shortening of the center warp is based on the assumption that all 3 warps are straight lines. In reality, the warps leading to the doors will be more curved than the warp leading to the clump weight when the gear is square. This means that the shortening of the center warp needs to be very slightly more than the lengths in the table. We are now going to look at what happens when the center warp length is corrected for a 3-warp rig using models in the flume tank. We will go through the procedure of measuring the door spread and altering the center warp length accordingly to square up the nets. Here, the nets are being shot with all 3 warps of equal length, and the doors are starting to spread the gear. As we saw earlier, as the doors spread, they pull ahead of the clump weight, and this causes the nets to distort. We can see this very clearly when the film speed is increased. In this example, we have the equivalent of 275 fathoms of warp out. We have measured the door spread at 250 feet. By consulting the table, we can see that in order to square up the gear, we should shorten the center warp by 4.7 feet. We will now haul in the center warp by the equivalent of 4.7 feet and watch the effect that this has on the gear. Here, the nets improve in shape, but they are still distorted. If we watch the doors as the warp is shortened, we can see that they are spreading more, allowing them to pull still further ahead of the clump weight. The reason for this is that as we haul in the center warp, we are taking up more load on it. Hauling in the center warp reduces the tension in the outside warps, and this allows the doors to spread out yet further. As the door spread has now changed, we have to measure it again and recalculate the shortening of the center warp, but this time using the new door spread. Our door spread is now about 300 feet. The warp out is still 275 fathoms. Using the table, we can see that the center warp should be 6.8 feet shorter than the outside two warps. It is already 4.7 feet shorter, therefore we need to shorten it again by the difference, which is 2.1 feet, to try to square the gear up. When we look at the gear now, the nets are still not symmetrical, because the doors have spread still further out. We have to check the door spread again. This gives us a new spread of 325 feet. Looking at the table, for 275 fathoms of warp out and a spread of 325 feet, we need a center warp shortened by 8 feet. This means that we must haul in the center warp by a further 1.2 feet. We now check the door spread once more and find that there is very little change. Looking at the gear, the doors and clump are in line. The nets are now square. This means that the gear is now in its optimum fishing position. It is good practice to check the door spread regularly. If at any time the warp length is altered or the door spread changes, the tables should be checked to make sure that the center warp is shortened by the correct amount. Using the tables is not a one-off process, but a gradual process whereby the final answer is homed in upon in stages. We now haul the center warp in by 2 feet more than that recommended in the tables. The nets are still in a good fishing shape, with very little